Come up with your own quadratic equation whose solutions come from the set of irrationals. Okay, irrationals are going to be your square roots. So let's use our very easiest possible. If your answer's got to be a square root, let's just do this. Your quadratic is ax squared plus bx plus c. Okay, let's cut this out. Let's cut out your x. So what if I just have this? X squared equals 7. Okay, now solve it. What number times itself is 7? It's going to be the square root. So it's going to be x equals plus or minus square root of 7. Okay, there's your answer. Your answer comes from the set of irrationals. So a slick equation is just going to be x squared equals 7. Come up with an equation whose solutions are imaginary. Same thing, let's just keep it easy. Quadratic, so it's got to be x squared. And imaginary would be like this. What number times itself is a negative 7? And that is imaginary. Okay, let's review the imaginaries. Let's practice. If you just add like terms, a negative 3 and 18, that's going to be 15. 5i and a minus 7i is going to be a minus 2i. Done. Multiplication. Here's what you got to remember. I is always the square root of a negative 1. I squared equals a negative 1. You have to memorize those. If I multiply these, I'm going to get a negative 6i squared. But a negative 6, I'm going to replace I squared with a negative 1. So it's going to be a negative 6 times negative 1, which is positive 6. Times 5i. It's going to be 30i. FOIL, you got to do distributive. 7 times 2, that's 14. 7 times minus 3i is minus 21i. Minus 6i times 2 is minus 12i. Minus 6i times minus 3i is 18i squared. Okay, you're going to swap out an I squared for a negative 1. 18 times negative 1 is negative 18. You're going to link negative 18 and 14. And those total and give you a negative 4. Then you combine these two guys, a negative 21i and a negative 12i, and you're going to get a negative, is that negative 33i? Done. Call it good. This is where your imaginaries really start to play though. It all comes down to this equation. So let's solve it. And you should notice that you are missing the x. You're missing it. So if you're missing it, just undo it. Let's minus 96 minus 96. We got 8x squared equals a minus 96. Divide by 8. Divide by 8. X squared equals, what's negative 96 divided by 8? Negative 12. Okay, so now this is the imaginary. What number times itself is a negative 12? It's impossible. Square root. You got x equals plus or minus square root of negative 12. X equals plus or minus square root of negative 1 times square root of 12. That's your I right there. And the square root of 12 is the same as the square root of 4 times square root of 3. So it's going to be 2 times the square root of 3. So x equals plus or minus 2i times the square root of 3. I to the 52nd power. What if you have I times I times I times I 52 times? You want to think in terms of this. How many I squareds are there? Because an I squared is just a negative 1. So how many I squareds are there in 52? How many 2's are there in 52? There's going to be 26 of them. So this is legal. You're going to rewrite that as I squared to the 26th power. You're going to swap out in place of I squared a negative 1. Negative 1 to the 26th. What's a negative 1 times itself 26 times? It is a positive 1. What about an odd one? What if you have I to the 63rd power? So how many 2's are there in 63? There is going to be 31. But that doesn't count for all of them, because 31 2's just takes you to 62, and there's really 63 i's, so I need to account for that 63rd. Okay, now swap out in place of I squared and negative 1. So you got I times a negative 1, 31 times. What's negative 1 times itself 31 times? It's just going to be a negative 1. What is a negative 1 times I? Negative I. Alright, 10. Let's practice. Let's solve these 4 equations. Okay. 10, look at it. And hopefully you notice that there is no x. It's missing. So let's just undo it. Let's minus 8. Minus 8, you got 6x squared equals minus 30. Divided by 6, divided by 6, you got x squared equals minus 5. What number times itself is minus 5? I know that's going to be imaginary. Square root the left, square root the right. It's going to be x equals plus or minus the square root of negative 1 times square root of 5. So it's going to be x equals plus or minus I times the square root of 5. Let's get everything on the same side. So let's go m squared minus 3m minus 40 equals 0. Does there exist two numbers that times and give you negative 40, add and give you negative 3? Yes. Negative 8 and a positive 5. So it's going to be m minus 8 times m plus 5 is 0. What times what is 0? It's got to be a 0. M is going to be 8, or m is going to be a negative 5. Okay. Keep going. So look, you got all three. You got a p squared, you got a p, and you got a number. Let's minus 6. So you got p squared plus 14p. What is that going to be? 48 equals 0. So what is going to times give you 48, add and give you 14? 8 and 6. So it's going to be p plus 8 times p plus 6 equals 0. So p's got to be a negative 8 or a negative 6. Minus 9. B squared plus 12b minus 13 equals 0. What's going to times and give you minus 13, add and give you 12? It's got to be a 13 and a 1. 1 is negative, because 13 minus 1 is 12. So now it's going to be b plus 13 equals b minus, or times b minus 1 equals 0. So b's got to be a minus 13 or a plus 1. $11. Okay, that's a good question. Would the solutions be real or would they be imaginary? Alright. Well, this is a good question. So, you have some number multiplied by itself 247,656 times. But your answer is negative 1. This has got to be imaginary. Because there's an even amount of pairs. You're multiplying it by itself an even amount of times. So they're going to be paired up. And whenever numbers are paired up, a positive, if a positive pairs with a positive, your answer is positive. If a negative pairs with a negative, your answer is positive. So when you multiply in pairs, your answer is always positive. They're saying your answer is supposed to be negative. Well, that's only true in an imaginary number world. Okay, this one, would the solutions be real or imaginary? X, some number, times itself 247,656,253 times. But your outcome is a negative 1. Is that plausible? And yes, it's going to be real. It's real because this number right here is odd, so that means there's going to be a positive times a negative, which is going to be a negative, and that's what they're saying we end up at. So 12, graphing practice. How many more do we have? This can be it. Okay, interest of time, I'm just gonna do, I'll start you off on 12. This one, the A is 1, the B is -4. The trick on this, the C is 0. Let's do this one. A is -2, B is -4, C is -5. Okay, C is your first dot. So -5 on the y-axis, here we go. Now I need to know my line of symmetry. My line of symmetry is going to be -b divided by 2a. So it's going to be a -4 divided by 2 times -2. So it's going to be a +4 divided by a -4. +4 divided by -4 is -1. So my line of symmetry is going to be right here at -1. So if I have a table, x, y, if I plug a -1 in, what is going to come out? So let's plug a -1 there, let's plug a -1 there. It's going to be a -2 times a -1 squared, minus 4 times a -1, plus a -5. So -1 times -1 is +1. +1 times -2 is -2. -1 times -4 is +4. And then -5. So what's a -2 and a +4 and a -5? And it should be, is that a -3? -3. So if I go left 1, down 3, there is my vertex. And I know this dot right here at -5 reflects across the line to right there. Your parabola looks just like that. You know it's going to be upside down because your A is negative. Anytime your A is negative, it's upside down. Last question. Okay, what is an imaginary number? What's the difference between a real number and an imaginary number? What makes an imaginary number imaginary? And it's this right here. What number squared is going to give you 4? Well, the answer is going to be 2, because 2 times 2 is 4, or it's going to be -2, because -2 times -2 is also 4. That's the real. So this is the real world. The imaginary world is this. What number times itself is a -4? And this is imaginary because any number, no matter what, fractions, decimals, negatives, positives, square roots, any number times itself an even amount of times will always be positive, no matter what. If I have a number and I multiply itself over and over an even amount, there's always going to be pairs. Pairs are always positive. So here's what it's saying. You're multiplying a number twice. That's an even amount. Your answer is negative. Well, that's illogical. Your answer can never be negative if you multiply anything twice, or 4 times, or 6 times, or 8 times. If you multiply something an even amount of times, it's always going to be positive. Can never be negative. So this is an imaginary description.